This conference will now be recorded.
Okay, cool. So welcome everyone. I'm Mangesh, as introduced by Hemant, and today we will try to explore gRPC with the .NET Core. And the agenda for today's session will be to check what is gRPC, to check the gRPC basic concepts. Let's have one demo app application, like creating the services as well as the client. Next, we'll explore the gRPC types. Then we'll try to see what is gRPC Web, and let's have a demo app to do application app with Blazor WebAssembly, and as a backend we will use the gRPC. This will be completely into the .NET Core. The basic question: what is gRPC? Basically, gRPC, it is an open source RPC framework which has been developed by Google. Next, uh, this gRPC was open sourced by Google in 2015, and this was their internal project, which they have used for their internal services, and this is completely owned by Google itself. So, and next is it is used efficient. It is used efficiently. It is used to efficiently connect polyglot services. Means the services which are in different environments, generally into the microservices architecture, connecting mobile devices as well as the browser clients. Next, it provides a way to client apps to call server methods as if they are the local objects. I mean, uh, many of us have worked on the REST applications. We know how to call the REST services. We need to create. We need to as far as the I mean uh, I mean .NET apps are concerned, we need to design some API clients. Then we need to have the HTTP client. Then we need to we'll need to use the some post methods of that HTTP client. But with gRPC, with the concept of gRPC, it provides a way to the client apps to call the methods, to call the server methods, or what we can say, the server service methods, as if they are on your on local machine, or they are like your methods on the classes. So let's see how we can do that in the demo itself. So when we talk about the gRPC core concepts, basically gRPC has two main parts. First one being the protocol, which is an HTTP2, and because of that, there are plenty of benefits that gRPC offers. Generally, what we use is on conventional REST services is HTTP 1.x. Okay, means 1.1, 1.2 maybe, and with HTTP2, it has plenty of benefits like security. That's the one. Next is the streaming options, which is not possible with conventional HTTP. We don't have any capability of streaming with the REST applications, like for today. And next is the data serialization. We all know we use JSON for the data serialization, but gRPC uses its own type of serialization, that is Protobuf. So let's try to explore the Protobuf as well. What is Protobuf basically? How we can design the services? What it is exactly? That will come to it in next parts. Okay. So continuing the core concept, protocol buffer. So protobuf is the flexible, efficient, and structured mechanism for serializing the data. It is just like our JSON, but it is more flexible, efficient, and structured one. It is used as an ideal. Ideal is an interface definition language. Next, they are used for service interface and message definition. Basically, we use protobuf to define our services as well as the messages as well. And this same protobuf is distributed among clients the same protobuf that we have developed on the server is distributed among the clients, and they in that way it acts as an ideal also. Next, they can be used to generate the source code for your choice of languages using compiler using compiler ProtoC. So ProtoC is a special type of compiler which is used to compile our protobuf files. So we'll see how we can use that using Visual Studios. Okay. So if you see, oh, sorry. If you see the basic structure of your protobuf file, you can see on the screen. It first part first part is basically the syntax, that is proto 3. Proto 3 is nothing but the version of proto. Next is the C sharp namespace, means if you are generating if you are using a C sharp code and developing a grpc services, then that C sharp namespace add all these services under that particular namespace. Next part is the service definition part. The service definition part. Next is the message. Next part is the message definition. Whatever the messages, means incoming types as well as the outgoing types for particular services are defined by using messages. And our service part is actually it defines our service methods that we want to check. So okay. So now how the communication between grpc server and client happens. Okay. So generally what happens is grpc server implements a protobuf service interface and runs a server to handle call to its service methods. On the other hand, we have clients. Okay. We have the clients which are developed into the various languages like Android or C++ or C sharp or Java, which uses the stubs or which uses the same protobuf file to generate the stubs which have same methods and signatures as the server methods. So basically what happens, we develop the services using protobuf file. Then that protobuf file is used to generate the stubs which is distributed to the clients, and client use that stub to the call the service methods basically. So this is how the communication between grpc servers and client happens. So whenever the client send the proto request, and basically the grp service sends us the response. I mean that's the typical client, that's how the typical client server communication occurs. Okay. So let's see how we can create a service, how we can create a client, and how we can call the service, call the grpc service by using .NET Core and by using project. So basically I have created these projects, and let's concentrate on this. So this is my grpc service actually. So this is my grpc service project. Visual Studio has template for it. So in order to add a grpc project, just click on new template. You just name it something, create. It will add. This is the standard process to add a grpc service. The service template is been provided into the Visual Studio itself. I will not add that, and I'll just undo all the things. So now what we want to do is we want to design a service, or we want to design a service which will be distributed to the clients, and that client will execute that service and we will get the output. That is the demo that we are going to do. So first thing, we have talked about the protobuf files, right? So protobuf file. So first thing that we want to do is we want to generate a protobuf file. So what we'll do is here here you can see my folder, that is protos folder, and there are some files like grid.proto and sample service.proto. So first thing that we want to do is we just need to add a new item which will be a protocol buffer file. So what this protocol buffer file contains? This protocol buffer file is used as an ideal. We talked about it. Also, it contains the service methods as well as the interface. I mean, if you go here, they are used for service interface as well as the message definition. So with this protocol buffer file, let's try to add some service methods as well as some method definitions as well. So what we will name it as an so standard, let's name it as an hello world. Here you can see this is the syntax. This is the syntax which tells a compiler, means basically uh, say that syntax of or what syntax of the protobuf that we are going to use to compile this particular file. So when we add this file, next thing that we want to do is just click on it and just change the build action for this. Just change it to protobuf compiler. Here you will see it will ask you what means these are some options for which we can generate our grpc stub classes. You can for client server as well, or client only, server only. So yes, we are implementing the protobuf at server end, so we'll just keep it as a server only. Oh, sorry. So this is server only. Let's compile it. Okay, it is a building now. So first thing that we need to do is we need to define our message structures, right? I mean message structure. So let's call it as an hello world request. This is our message which we will use for request one. How do you do that? And next, this is basically a structure. Next, we'll define some properties into that. This will be like request to one. So now, excuse, now while defining the protobuf file, we define a number each and what is these field numbers used to identify field the data. Basically whenever it is in json we have like age colon and then there is some value to it. So in the same way in protobuf what happens is this number one is used to identify the request into that. So that is to identify the fields into the binary encoded data. So this is our first hello request. This is the request, and what we will have is hello world response, which again will have a string property, which will be one. Now, what we want to do is we want to define a service. hello world service. So in this, we want to define a method. So the method will be say hello to world, which accept hello world request, which will returns hello world this one. So this is our basic protofile. So this is how we use it. If it, then this is completed. So in short, what we can say is this is we have defined. Now what we need to do is we need to implement this interface as a to the services, like we have said over here that they are used to they are used as an for the service to define the service interfaces. So now next part of in this demo is to define the service. So in order to do that, let's add one class. Let's say hello world implementation. Let's add it. Okay, so how define this interface. Now what we need to do is we need to implement this interface. So in order to implement this interface, let's get an this is our service. Oh, this is our service which has one service page. So what is happening here? I mean, if we go to the service page, so this is a abstract class which implements all the methods for us, and then it gives us the proto. What proto C does is it converts our this proto file into some abstract class where the methods or these service method as well as these message definitions are present, and we use this service based class to expose this method to the implementation. So from here we can override this method which we have defined into the proto file. So what we will do is we are overriding this method. We'll just return. Basically, if you see it, let's do that, and here we are done. We have done is we have inherited our implementation from this base, and we have override this method, and the method or we just return a simple response we are sending back to the client, that is welcome to Surat first. Let's build this application. Okay, so we are good with the building. Now in this section we have defined the service part of our grpc. Now what we need to do is we need to consume this service into some application or into some application that we generally we call it as a client. So in order to add a client, I have added one console application. So what we'll do is, so whenever now we have implemented the service. Now in order to implement that service at the client end, what we need to do is we just need to copy this path, paste it over here, I mean, it over here. Right click it. Here the subclasses. Just generate the subclasses for the client only, and just click OK. So I build this. It will be completed. Now coming to implementing implementing or calling the service part. So basically, implementing client is divided into three parts. First one being the creating a channel. So creating a channel is nothing but it is creating a channel for that particular address. For that, we use a package which is present. Let's say it localhost of 5001. First thing that we need to do is create a channel. Next is create a. Now, how do we create a client? So the client is equal to, let's go and let's check again the namespace. Hello world service dot hello world service client, which takes channel. Next, we just call the method and have the response. How do you do that? We do client dot say hello to world. So I guess I misspelled waste equals to. So let's write down this response, that response. Now let's do this. It is successful. Now what we do is let's what we do is let's run the application. Before we do that, let's just multiple startup.
Hello, Mangesh.
Okay.
Yeah. We are not able to hear you. So, were you speaking or were you not speaking at this time?
No, I was speaking.
Okay, so we lost you for a moment. I think maybe last 30 seconds or something.
Okay, cool. Just let me know. Okay.
Yeah, sure.
Am I audible now?
Yeah, clearly.
Okay. So we ran into one error, but what it says, it is unimplemented. So one more thing is that what that we need to do is into startup.cs, we need to map endpoint our particular service. So if we go here and we just map, because this is we need to map our endpoint to our implementation basically. So if we go back again, build it, and if we start it, I guess, yeah. So here you can see, here you will be able to see the response from the service actually. I mean, yeah. So if you go here where it is, yeah, and if you keep the breakpoint over here, and let's restart it one more time. So here you can see the request which is coming from the network, which we have sent as an hello, and we are returning our response as an welcome to Surat Tech Fest. So so this is our response which we have displayed on the console, and let's continue with that. Maybe let's break it, and here you can see the response as well. So this is welcome to Surat Tech Fest. So imagine this, implementing this simple client server or simply get call with the rest. We have to write down plenty of things like writing HTTP client dot get, writing headers, something like that. But here with the protobuf, what we are doing is we are calling our service method just as an another method into the class, and we are getting the response as well. So this is how we can develop our service as well as the clients. So this client, it can be different. I mean, this is for C sharp. The Java client will be there. C++ client will be there. What we need to do is we just need to focus on our protofile, and we design the we design the service using protofile, and that protofile will be distributed to the clients, and with the clients with the compiler designed for that particular language, will generate these stubs for that particular client. It may be Android, it may be Java, or it may be C++, and using that stub, they can call our service method easily. So there won't be like specifications, there won't be any uh, there won't be any debates, or there won't be any discussions among how to call it, why to call it, something like that with this protobuf. I mean, yeah. So coming to the PPT again, we have seen how do we create a service, how do we create a client, and how do we call the service. So next thing is the grpc type. So what we have seen is basic a unary type grpc service. It's a simple and basic client server, client and server type of, or unidirectional kind of service, in which we send the request, we get the response, and we consume the response. That's it. But another there are like four types of grpc types. First one, unary. Next is the client streaming, where the streaming from the client happens, and server will accept it as an one request. Next is the server streaming, where server streams the data to the client in response to a single request which is coming from the client. Then there will be a bidirectional streaming as well, in which the client and server can simultaneously send and receive the data into bidirectional streaming as well. So next thing is grpc web. So we have seen what we have seen right now. We have consumed our grpc service into a grpc client, which is into the C sharp. But currently, grpc is not supported in the browser because of the inability to implement both http 1.1 and http 2 as well, because http 2 as well. Next problem, that adopting grpc to browser, built-in support in the browser is sending the grpc trailers in the request and response. Because of these two main reasons, the grpc is not supported as a native thing into the browser. So what is the alternate for that? Alternate is to use the grpc web. So what is grpc web? Basically what the concept around grpc web is, browser will act normally, the way it acts right now. It will just send a http request, but then the concept here tells is to have a grpc web proxy before our service, that is a grpc backend. What it will do is it will accept the things from grpc browser, and then it transfer it to the grpc backend. So this is there are some proxies like NY or go away, HPAC. There are some proxy services, grpc web proxy services, which are used. So but we, in case of our .NET Core, instead of any proxy, what .NET Core do is we use a middleware which is app.grpc use grpc web. So I'll tell you how to check that, or how to implement that. But instead of any proxy or anything, we use a built-in middleware which .NET Core team which .NET Core has provided us for the grpc web. So next, again, let's see one demo app, which is generally a to-do application, which has been developed by using Blazor WebAssembly, and at backend it uses gRPC through the gRPC web. Okay, so mm, okay, so let me shut it down. So if you see here, this is my sample application, and this is my sample application. This is my to-do service, which basically uses a gRPC web. I mean, backend. Let's I'll explain you the backend, but before that, let's concentrate on the startup class. So the basic that we want to use is, we just add one service to the service collection as an add grpc. Then we add some cores as well, and these are the headers that we need to expose so that it could be consumed into the browser, like grpc status, message encoding, and accept encoding. And next thing that we want to do is, this is this is let me- you can see, this is the middleware which will act as an intermediate between our grpc service and our any client app, basically the client app which is running on the browser. So in our case, it will be a Blazor WebAssembly app. So whatever the things will come, this middleware will handle these things, and it will pass to our grpc services, and after the operation, it will pass the response back to the web clients. So let me run my this service. So this is my service which I'm running using .NET Run. This is running on localhost. Okay, so now uh, this is our assembly app. Here you can see, if you see the network. Oh, okay, so if we add this and if you see the network, So all this is the content type which is been sent is application grpc web, and it is being served from our grpc app basically. So in order to use any grpc app, what we need to do is we need to with .NET Core we need to use this middleware, that is app.use grpc web. Then we need to enable the grpc web for that particular services, and also we need to add our course as well for that. And yeah, so in order to use grpc into your web browser, we need to go for the grpc web. Next thing that I forgot to tell you in previous demo is the toolings that we need at the client end. So if we see the packages that we need is so there are basically three to four packages that we need. So this is a the Google Protobuf. Uh, this is the package. Next is the grpc .NET.client. Next .NET.client.web and grpc tools. These four packages that we will need so as to make sure we can build the client easily or client properly. So so this is how we can use the grpc web as well. Now coming to the discussion, like why we should use the grpc. First one being a performance, because the serialization we use the protobuf for the serialization. The performance of the performance of the services or performance during the request and response is much improved as compared to the JSON or in that sense XML. I mean, no one used that in today's world. Next is the code generation. You have seen it, that code generation part in between server and client is so easy. I mean, we don't need to design our API client and use the HTTP client. We don't need to go for that. We don't have we don't need to do much in that case. The code generation is simple. Just use the protobuf file, generate the client, just call the method. Next, there is a strict specification present for the protobuf file, which in that case no formal specification for REST exists. Next is a streaming support. Like we have seen into the grpc types, there are four types. There are three types of streaming support, like bidirectional, client side and server side streaming support, which is not possible with current http 1.x. And next, this is a well suited for the microservices, for polyglot environments and network constrained areas. Like if there are services which we need to exposed into the different environments, like into different environments like Java or Java or C++, then the grpcs are the best. These are well suited for the microservices environment as well. So basically this project was started with Google, and they have used the concept of grpc into their internal services. So yeah. uh, okay, any questions on this? Hello?
We do not have any questions, Mangesh, but that was a good walkthrough, as I must say, and quite
Yeah.
interesting. Naren bhai, do you have any questions?
And can you hear me, Tejas?
Yeah, we can hear you.
Yeah, just Mangesh, I was wondering about GRPC and how it is. I mean, is there any similarity or differences with WCF of Microsoft?
Yes. Actually, I was coming to that topic, but I guess I have not added them into the slides. But yes, there are plenty of similarities, and basically, the gRPC will be replacement for the WCF into the new .NET ecosystem that we are having nowadays.
Okay, okay,
With the with the .NET Core and .NET 5, which is coming next, and in the near future it will be .NET 6. And what they have decided is they have stopped porting WCF. They did not port any component of WCF or WCF to the .NET Core ecosystem. So what they are suggesting is to go for the gRPC instead of WCF, and there are plenty of similarities. Like if you see
okay.
your service contract, it becomes your
Mhm.
service, right? Data contract,
Okay.
it becomes your message. I mean,
Mhm.
there are plenty of similarities for sure. Yeah.
Okay, Mangesh, I did really enjoyed your session very much. So thank you very much for the
Thank you,
yeah,
Naren.
very good.
Thank you. Yeah.
Thank you.
So Mangesh,
Okay.
we do not have any further questions, but if you really want to continue, then we have some time left on the clock, and you can continue if you wish to. Otherwise, everyone.
No. I'm good. Actually, I had prepared 45 minute session, basically. I know. Okay. So just connect me on this. I mean, yeah. So you can check
Sure.
me on GitHub.
Uh-huh.
Yeah.
Okay, thanks for your time and the presentations, Mangesh. Hope to see you on the future events of Surat Tech Talks. And I
Indeed.
hope that you will continue with such terrific hands-on sessions.
Indeed. I'll do that. I'll do that. Yeah.
Okay, then, bye
Okay.
for now, and thanks for your time once again.
Yeah. Thank you.